Hello everybody, hope you're all doing well during the lockdown. Today's lesson 6 of our Forces 1 unit, and it's called Distance Time Graphs. And our objectives today are, I can plot a line graph and draw a line of best fit, and I can calculate a gradient to work out speed. And gradient is just a scientific or mathematical word that means how steep is a line or how steep is a hill. So last lesson you looked at how and when your speed changed as you travelled to school, and today we're going to quantify this. This just means we're going to add some numbers to make everything make sense. So let's look at a Saturday morning shopping trip. You might have done this yourself. So on the right hand side we see a map of Frome. You can see a car park near the top left and lots of roofs of lots of shops. You might recognise some of this. So let's say on a sunny Saturday morning, you and a friend get dropped off in Cork Street. So the red circle there denotes where Cork Street is and where you might have been dropped off. Then you walk over to Greggs on Scott Road. You haven't had your breakfast yet, and you and your friends go to Greggs, and perhaps you get one of those vegan sausage rolls or a pasty or something like that. And it's right there. And then you go over to Boots on Marketplace for some smellies. Could be a can of deodorant, bottle of water, who knows, they sell all sorts of things at Boots, don't they? But you go over to Boots to go and pick something up. And then, oh dear, you've forgotten your cinema tickets and you have to rush all the way back to the car park to go and get them from your mum or your dad or your uncle or auntie or grandparents, whoever's dropped you off. So this is one way that we can visualise that journey. We've got a picture of the car park on the left, then an arrow to Greggs, an arrow to Boots, and then another arrow going all the way back to the car park. But that's not going to help us in answering our objectives today. So now we know where we're going, what we need are some times and some distances. So let's say you're having quite a lazy Saturday morning and you get to the car park at 10 o'clock in the morning, and you and your friends walk 80 metres to Greggs, and it's going to take you a couple of minutes. Well, if you arrived at 10 a.m. and it takes you 2 minutes to walk, then you're going to arrive at Greggs at 10:02. Now you're in Greggs for 3 minutes because it doesn't take long to pick what you want and then pay for it, and then you leave at 10:05. Boots is 60 metres away from Greggs and it takes you just 1 minute to walk. Can't be that many people on the pavements at that time. So you're going to arrive at Boots at 10:06. Now you're in Boots for quite a while. You're in Boots for 8 minutes, getting what you want and then being served and then exiting the building. And then you leave at 10:14. Now you need to rush back 140 metres back to the car park, and because you're power walking to go and get your cinema tickets, it only takes you 1 minute. So what would this look like then on a distance time graph or a DT graph? Well, on the right hand side I've drawn a graph that I think could represent this journey quite well. The x-axis is time in minutes, and it goes from 10, 10:01, 10:02, 10:03 all the way up to 10:15. And on the y-axis it says distance from the car park and then metres. So whenever we draw a graph, we write down a title for the axes and then we give a unit as well. So distance from car park is the title and metres is the unit. And on the x-axis, time is the title and minutes is the unit. On the left side of the graph, I've got A, B, C, D, E, F, G, H and I, and this is what's going on during our journey. So we arrive at 10 o'clock at the car park. So distance from car park is going to be 0 metres, okay, because we are at the car park. We haven't gone anywhere yet. We're still at the car park, and that's at 10 o'clock in the morning. So I put the red dot where it says 10 and then 0 metres from car park. Now we're going to walk 80 metres in 2 minutes. So we arrive at 10:02 and it's 80 metres away. So we put a dot there and then join it up with a straight line. Now we're in Greggs for 3 minutes, so we're still 80 metres away from the car park. Okay, we're not moving anywhere from the car park, but we're just waiting and waiting and waiting for 3 minutes up to 10:05. So we join those points up with a straight line. And then we're going to be walking 1 minute, 60 metres in 1 minute. So we were 80 metres from the car park, So we walk another 60 metres from the car park, so that adds up to 140 metres altogether. And then we connect that. And we waited in Boots for quite a long time. We waited in Boots for 8 minutes. So we're always the same distance from the car park all the way through this time. So we're still 140 metres away from the car park for all of those 8 minutes. And then we connect them up. And then we rush all the way back to the car park, and it only takes 1 minute. And then we connect that up. So what you can see is at the end of the journey at 10:15, we are 0 metres away from the car park because we've ended up back at the car park itself. So if we were going to put those letters on the graph lines, wonder where they would go. Well, A is right there because that's the time we arrived at the car park. B, this line, this incline, this line going upwards, shows that we're walking 80 metres in 2 minutes. And C shows the time we actually arrive at Greg's, so 10:02. D shows that we're staying there for 3 minutes and that we're leaving at 10:05. E shows we walk an extra 60 metres, so the line carries on going upwards at an incline for another 60 metres over a 1 minute period of time. And then we arrive at 10:06. G shows that we're staying there for 8 minutes, so from 10:06 to 10:14 we've stayed there for 8 minutes. And then we can see that at the time, at the end of G, it's 10:14. H, we're rushing back to the car park, which is the full 140 metres, and it only takes 1 minute. And then I, our journey has ended at 10:15. So you might remember from a couple of lessons ago that distance is a scalar. So we know nothing about the direction of the journey. We don't know if we're going forwards or backwards or left or right. Okay, it's a scalar. All we know are the distances and the times. We don't know what direction anything's going in. So here are 3 sets of questions that you can do. The red one is the easiest one, the green one is medium, and the purple one is the trickiest one of all. You're more than welcome to do all 3 if you like, and if you are unable to see this, at the end of the video, all 3 of these are blown up much larger, so you're able to see them much clearer. Okay, so here are 3. You can choose one. Draw a distance time graph to represent the journey, just like I did a moment ago. So you might want to choose the cycle ride, you might want to choose the flower shop, or you might want to choose the hike. And as I said before, the red one's the easiest, green's the medium, and that purple one is a real tricky one. Okay, so this is an opportunity for you to pause the video and have an attempt of one of these. So here are the answers to the questions. These are the graphs that you perhaps should have drawn. Don't worry if you didn't get it right first time. This is quite a tricky task to do. So the red task, the cycle ride, is drawn on the left. You can see I put like a red border around it and I've drawn it all, the lines all in red. The green one is the flower shop, so green border and green line. And the hike is the purple border and purple line. So you might want to pause the video, look at your graph, look at the one you've got here on the screen, and then make a comparison between yours and my graph. Okay, hope you did well on that one. If not, just email your teacher and we could offer you some more support. So to work out the second objective, how can I calculate a gradient to work out speed? You need to use your graph to be able to do that. And it looks really tricky at first, but I promise you this isn't as tricky as it looks. So what we're going to do to work out speed, we need to work out the gradient. So if you ever have a distance time graph and you're asked to work out speed, then you need to calculate a gradient. So typically the gradient is rise divided by run. And in maths and science, there's lots of ways that you can express the gradient, but the easiest one I find is rise divided by run. And if we look at This is because the equation that we know is speed equals distance divided by time. So the rise is distance, the run is time, and we need to divide them. So this is what we're going to do. Now you have to draw a right angled triangle on that line of best fit, and you can draw this wherever you want so long as the long side of the triangle, the hypotenuse, is on that line of best fit. So I'm going to choose my red line right there. I've got it from the 0 time going up to the 6 seconds time. But I promise you can put that line anywhere you want on that line. You'll still get exactly the same answer. Now this gradient is going to tell us the steepness of this line, or it's going to tell us the speed, the average speed. And because that line, the steepness doesn't change, that's why we can draw this line as long or as short as we like, because the steepness is the same all the way along. So I'm going to turn it into a right angle triangle, just like this. And just for the sake of the graph, I'm going to colour it in so that it's really, really obvious. And your triangle always needs to look this way round. So you draw the line going up, draw down, and then across to the left, and then just connect it. So the right angle needs to be always in that place if the line's going upwards. So now we've drawn our right angle triangle, we can work out the rise. And the rise just means the height of the triangle. So that's indicated by the purple line there. So I look at where the line, or my arrow, goes over to the y-axis, and it goes over to the number 12 and the number 0. So the height of the triangle, the top part is 12 and the bottom part is 0. And all I've got to do to work out the rise is take away those two numbers. Now my numbers are 12 and 0. That makes it nice and easy because 12 take away 0 is 12. So that would be 12 metres. And because distance from start is in metres, my 12 metres take away 0 metres is 12 metres. So that's where the metres part comes from. So now I've worked out what's called the run. And this is just the base of the triangle. So I do the same thing again. I'm going to draw a purple line where the run is. And I've put arrows to show where the run starts and where the run ends. And the numbers there are 0 and 6. And just like we did with the rise, we have to do the same with the run and just take away those numbers. So 6 seconds, take away 0 seconds is still 6 seconds. Now what you've got to do, you've got to take the biggest number, take away the smallest number whenever you've got a distance time graph where the line is going upwards to the right, where it's an incline. So the biggest number, take away the littlest number. So now we've got our rise as 12 metres and our run as 6 seconds. We're going to use our equation, rise divided by run, and now we just plug that into the equation. The rise is 12 metres, the run is 6 seconds, we divide them, and it calculates our speed automatically for us as 2 metres per second. Nice and easy. See, it's not as hard as it looks. So what I'd like you to do is have a go at this yourself. So here's a distance time graph I've already drawn for you. Number one, using this graph, work out the speeds between A and B, B and C, C and D, and D and E. So get some practice using, maybe you can put the paper in your book over the screen. You'll be able to trace through it, or you could draw it all out from scratch. So you've got really nice notes in your book. It's up to you. And then number two, what was the highest speed? 3, how many times did the journey stop? So you might remember from a minute ago, stopped means stationary. It's where you have a horizontal line. So the line doesn't go upwards or downwards. It's a horizontal straight line. And some people remember the word plateau because the first 5 letters in it are plate. And it looks like a straight plate. And that means stationary or stopped. And then question 4, how long was the person stationary? So that means for how many seconds was the person stationary for? So pause the video, answer questions 1, 2, 3 and 4, and we'll go through the answers in just a moment. So pause the video now and have a go at these. So let's have a look at some answers then. So number 1, between A and B, the rise is 6, the run is 6, so 6 divided by 6 is 1 metres per second. B and C, you can see it's a straight line. It's not, the person isn't moving, so their speed is 0 meters per second. And you'll see that between B and C, you can't draw a triangle. You can't draw a right angle triangle because all you've got is one straight line. You don't have an incline. And so whenever you see that, you can see mathematically it shows you that a plateau or a plate, a straight plate, a plateau, straight line shows you stationary. C and D, so the rise goes from 6 to 18, so that's 12. And the time goes from 10 to 16, which is 6. So 12 over 6 gives you 2 meters per second. And D and E is our straight plate, our plateau, and it's 0 meters per second. So now we've got those four answers, we can answer number 2. What was the highest speed? Well, we had 1 meter per second, 0, 2, and 0 meters per second. So the answer would be 2 meters per second, and that's between C and D. 3, how many times did the journey stop? Well, you're looking for the plateaus, the straight lines, and you can see it's twice, once at B to C and one at D to E. So there are 2 places altogether. And how long was the person stationary for? Now this is the trickiest question because there are 2 places where they stopped. So between B and C is 4 seconds, and between D and E was 4 seconds. So add that all up and you get 8 seconds altogether. If you're not sure about the answers, just pause the video, have a look at the answers and see if you can work out the method. And again, if you're still stuck, just send your teacher an email and they can go through this in more detail with you. So for a distance time graph, so there's my distance time graph on the right there, we have a line going up, a plateau, and then a line going down, what's called a decline. So A is an incline. It shows that it's a constant speed. That means that the speed doesn't change. It's the same speed all the way for A. And it's moving away from the start position. Okay, so the distance was at 0 at the beginning and it goes all the way up to 10 meters away from the start. So for A, we're moving away from where we started at a constant speed. B, a plateau, that means stationary or stopped. So we know that now, we've done that quite a few times already. And C is a decline. Decline means going downwards. And again, it's a straight line, so it's constant speed. So that means that speed isn't changing and they're going back to where they started. Okay, they're just moving back towards where they started. But what if you've got a curve? Now this is really, really difficult. This is for the really higher able students. So this is much trickier. So if you can grasp this and you're able to get your head around this, then really, really well done. You get lots more practice through year 10 and year 11 on this part as well. For this type of motion, the distance increases more and more as time goes by. So we don't have a nice straight line. That line, the steepness or the gradient, is increasing every single 2 seconds. We can see between 0 and 2, it's almost a plateau, isn't it? It's between 0 and 2 seconds, it's almost a straight line. It's only a small incline, it only has a small gradient. But if you look between 10 and 12 seconds, you can see the blue line is much steeper. So this shows because the gradient or the steepness of the line or the incline is getting steeper and steeper and steeper and steeper, the gradient is getting more and more and more. This means that the person is accelerating. They're getting faster and faster and faster and faster away from the start point. So what we can do, we can work out the speed at any single moment. So with the DT graph we had with a straight line, we're working out the average speed. Here, we can work out the speed at any moment of time. So I'm going to choose 8 seconds. So at that 8th second, what was the speed of the person in that journey? Okay, so that's what I want to know. I'm not worried about what happened at 2 seconds or 3 seconds or 4 seconds. I want to know at 8 seconds into the journey, how fast was that person moving at that moment in time? So what we're going to do is draw on a tangent. And it's almost the same thing really as working out the gradients using a right angle triangle. So a tangent just means a straight line to a curve. So I've drawn my red line where the time is 8 seconds. So the middle of my red line is where it corresponds on to where 8 seconds is. So I've drawn a straight red line, and you'll see that my red line hits that 8-second blue dot, but it doesn't hit all of that curve because it's a straight line, right? A straight line can't fit onto a curve, and that's perfectly fine. That's what you're supposed to do. But once you've drawn your straight line like that, all you've got to do now is do exactly the same before. Draw your right angle triangle and work out the gradients using the rise divided by run equation. So my rise is 23 meters at the top of my triangle and 8 meters at the bottom part. So take those two numbers away and I have a height or a rise of 15 meters. And the run, or the base of the triangle, goes from 10 seconds to 6 seconds. So the difference of time there is 4 seconds. Now I do the rise divided by the run because I want to work out the speed. This is how we worked out the gradient before, and that gives me 3.75 meters per second. So in your classroom, usually you would do a practical for this, but this is one that I found that you're able to do yourself if you want to. You don't have to do this, it's not compulsory, but it might be a bit of fun if you've got a younger brother or sister or a dog. You might want to do this. So you're going to plot your time for a 100-meter run. So 100 meters, you probably know how far 100 meters is by now. You probably run a 100-meter track. If you have a tape measure or something at home, you might be able to measure 100 meters. And you can measure your time to run that 100 meters, calculate the gradient, and then perhaps you could see if you're as fast as a cheetah or a zebra, an elephant or a squirrel, a pig or a chicken. So for this, you're only going to be plotting 2 points. So if you look at the graph, I've already put the blue dot at the 0, 0 origin on the graph, because at 0 meters into the journey, that's when time starts. So you're going to start at the 0 meters. Somebody will press the stopwatch, or maybe you can use your clock on your mobile phone. You run the 100 meters, and then your friend would stop the time. And wherever that is, you've got the 100 meters on the y-axis, go across to wherever the time is, put a dot there, connect it up with the straight line and work out the gradient. Right, as always then, these are the tasks that we do want you to do, and then you need to email these to your teacher as well. So task 1, define the following terms, speed and velocity. 2, what does an incline, plateau and a decline show on a DT graph? You should be really good at this now, I hope. Task 3, using a flow chart. So this is like where you have a box and an arrow, another box and an arrow. Explain how you could use a gradient to calculate speed. So it's like step 1, arrow, step 2, arrow, step 3. Task 4, if you did this task, which animal were you as fast as, and how could you go even faster? And then task 5, as always, postcard physics. Summarise this whole lesson using a half-page template. So you should pause this now and have a go at these 5 tasks. Now, for those of you wanting the extra sheets or you weren't able to see the questions from before, I'll just display those now for you. So here are those 3 questions, and I've put the table underneath for the distance and the times for each of these. So this might be easier if you are finding this quite tricky to begin with. And here is the worksheet and the graph already drawn out for you, ready if you want to do this practical now as well. All right, well, thank you very much. I hope you have fun doing these activities. Again, email your teachers if you get stuck with anything. Okay, guys, stay safe, and we'll tune in soon. Take care.